Welcome to the geotechnical podcast. Today we're going to be talking about offshore wind. My name is Thomas Langford. I'm the director for offshore energy at NGI, and we have two guests joining us from Australia and from Houston in Texas. So I'll introduce them now. Noel Boylan.
Hi, I'm Noel Boylan. I manage NGI's office in Australia, and we work across Australia and the APAC region.
And Catalina.
Yes, I'm Catalina Maldonado, president of NGI in the USA, with two offices in Houston and Boston.
Thanks so much. So today we're going to talk about offshore wind, and that's a really important topic for us at NGI and for society. So in the market, we see a movement now from the bottom fixed projects to floating wind in deeper water. What sort of similarities do we see from a geotechnical perspective between those two types of project?
Yeah, there's a lot of similarity, and some of it's subtle. In shallow waters where you fix bottoms, you have foundations such as large monopiles, you've jackets on pile foundations, or you even have jackets with suction installed foundations, so we call it suction bucket jackets. When you move to floating and anchoring, the types of concepts you can have, drag installed foundations, anchor piles, or even suction anchors, which are broadly the same type of concept that you have in the suction bucket jackets in shallower waters. So look a little bit different, but the underlying concepts are broadly the same. So
floating wind, obviously it sounds new. There are a couple of projects, but these concepts, are they new to us, or is this something that we've got experience with from oil and gas?
No, the concepts, they're not new, and there's a lot of history there from the oil and gas industry, using floating facilities, both temporary and permanent. And a lot of these foundations and anchors have been used already. So suction anchors, for instance, there's hundreds of them installed, maybe even thousands now around the world, holding permanent facilities in place. So there's a lot of knowledge there and a lot of experience in a very wide range of soils.
Thanks, Noel. Catalina, when we're looking at these two different sides of the market, what's the situation like in the US now?
In the US, we are dividing the market into three different areas, or four: the Northeast, Central Atlantic, Gulf of Mexico, and then the West Coast. For shallow waters, we're mainly using the bottom fixed installations. So in this case, we have throughout the East Coast and potentially in the Gulf of Mexico. And then for the California area and the West Coast, what is being considered is all the floating wind.
Mm-hmm. And do we see other challenges related to the floating wind projects on the West Coast?
Yes, there are several challenges from the geohazard standpoint. It is a highly active area from the earthquake standpoint. There is potential for liquefaction, also slope stability, as well as a shallow rock and stratified soils. So that represents a little bit more challenge when you are designing a foundation. Yeah.
Interesting. So Noel, you lead our office in Australia, but the office is not just covering the Australian market. It's really covering the whole Asia Pacific region. So how does the market look for you?
Yeah, it's interesting. For us, we work obviously in Australia, but we work all over the APAC region. And offshore wind is a market that's developing at different levels across the region. So, some of the first offshore wind farms that have gone into installation have been in Taiwan, and we've worked on some of those projects. And then you look at other countries like Japan and Korea that are at different stages of development now. And then coming back to Australia, we're probably at a slightly earlier position than those markets. We've had in the last few months the first feasibility license awarded down in the Gippsland region, and then some of the other areas are now out for application.
Mm-hmm. And what sort of differences? I suppose offshore wind is often seen as an industry that developed initially on large scale in Europe and has grown into these new regions. What sort of differences do you see in the projects around Asia, for instance, compared to Europe?
Yeah, probably soil conditions really around the region are very different. So take, for instance, in Australia, our soils tend to be carbonate soils, and these soils have particular behaviors that are different to non-carbonate materials. Then we move to areas like Japan, and we're dealing with very different soils again, and very layered soils and mixtures of materials. So yeah, you just across the region you see a wide range in soil conditions.
Mm-hmm. That's pretty interesting. I mean, I suppose in Europe we've got what we'd look at as a mature market, but we also see a movement now into, let's call it intermediate water with bottom fixed foundation. So projects like Seagreen that we worked on successfully with the suction bucket jackets that you mentioned earlier. That was very, very important, I think, for challenging the limits we've seen with water depths that people have assumed were possible with bottom fixed projects. But now there are new rounds opening up for floating wind as well. Maybe not exactly the same challenges that we've got off the west coast of the US, but certainly trying to work out how to build these projects at large scale efficiently and with robust and, let's say, not too expensive anchoring systems. So that's something that we're looking at a lot. But I can see that there is probably still a gap between the oil and gas industry and the offshore wind industry, and making sure that we actually bring in that expertise instead of trying to start with a blank sheet of paper, which may be the case for many people who are sort of encountering anchoring systems for the first time.
Yeah, no, that's correct. And there's a lot that can be learned from the experience from the oil and gas industry. So dealing with these different types of ground conditions, dealing with things like geohazards, the experience is there. And that can be just so important, particularly at the early stage of a project where people are making decisions about feasible concepts, that they tap into that.
I mean, I remember when we set up the Houston office, that was all about deep water floating projects. That was kind of where everything started for us in Texas. So it's pretty cool now to see things coming full circle and to be able to latch into that expertise potentially in the floating wind market as well. What do you think, Catalina?
Yeah, that's the idea. We have extensive experience on designing the suction buckets in the deep waters Gulf of Mexico, and now seeing this being exported towards wind energy in the potentially West Coast. It's something that we are excited about.
Yeah.
Yeah.
And we were just reflecting yesterday on the growth that we've had in our offices internationally. So Houston has been operating since 2002, and Perth, you're celebrating a 10-year anniversary this year. And I think we've grown to almost 60 people outside of Norway in that time. So that's pretty incredible, but I guess there's a lot of confidence and capacity to dig into there in these markets as they develop. Yeah, so Noel, like I've said, I mean, you've got a big team now. You've opened a laboratory in Perth. We're really going all in for this regional focus on offshore wind. Besides the ground conditions, what do you think are probably the biggest challenges in the Asian market?
Yeah, aside from ground conditions, it's probably the geohazards that you have to deal with. So in Europe, really the main one you have to deal with is the currents and scour and the effect that they have. But in our region, earthquakes, potential for liquefaction is quite significant. You have areas where you've tsunami risks. You also do have areas where you have very extreme currents and potential for large scar. But I think that's probably the main difference that developers need to take into account in their projects.
So, Noel, when it comes to earthquakes in our projects around Asia, what sort of things do we get asked to do by our clients? What do we look at in our analyses?
It's a range of things. First, it's looking at specific locations, looking at what the seismic hazard is, and what's the potential impact of that on the soil. So is there potential for liquefaction? Depending on what there is, these are things then we take into account in our design. So we use the soil behavior information that we measure in the laboratory and models to be able to simulate what's happened and see how that impacts the foundation. And often it's the case that, these earthquakes, even if they have some degree of liquefaction, there's an impact on the foundation, but it's not something catastrophic. So it can be accommodated in the design requirements.
Mm-hmm. You mentioned tsunamis as well. Is that a big issue, or what do you think?
Well, it's a concern in some areas of the region. So it's definitely something that has to be considered. So typically at early stages of projects, when we're doing desk studies, looking at locations, as part of that, we'd be looking at all the potential hazards and understanding at that stage how significant the tsunami risk is and if it needs to be taken into account in the design.
Yeah, it's interesting you mentioned desk studies. I guess this is something we've talked about a lot, but that's part of a sort of phased design approach. And what do we usually look at within these desk studies?
Yeah, desk studies, they're really important at the start of a project. And before you really go out and spend money on investigations and gathering data, desk studies look all the available information from the area. So information on geology, information on the soils, information on all the different things that are happening in the area. If there's infrastructure and things that passes over a site, that you have all of that gathered together. You can use that information to have a good idea of what the ground conditions are, and also thinking about what types of foundations may be feasible, and then use that to plan your survey. So rather than going out and doing a survey and finding out later, actually, we needed to get different information, we needed to look at different locations, it can really set you on a good footing for the decisions you make after that and before you really invest in surveys.
So that's what we're really saying. Desk studies are going to enable you to make good decisions within a project. Maybe not save money directly, but hopefully save money and time in the longer term.
Yeah. I think a good example is foundation concepts. Often people dive into a foundation concept because they think it's going to be the most cost effective or the concept that will be most achievable at a site. May not be feasible. And they may not find that out till later. And if they've invested in things like surveys and got the wrong information, they'll have to go out again and do it. So I think upfront, having a really good idea of what the feasible foundations are likely to be, it's de-risking for the project.
Cool. Catalina, I suppose one thing we associate, at least within geotechnical engineering and geoscience, with the projects in the northeast of the US has been glauconitic sands.
Yeah.
It's a exciting topic. It's a bit of a geeky topic for us, but could you just give us an idea of what we're actually talking about there?
Yeah. The glauconitic sands are very a specific type of soil. It's present in the East Coast mainly, and it's also being found in some zones in Africa and Europe. They have a very special behavior. They have originally they behave like sands, and when they degrade or crushed, they start exhibiting some clay-like behavior. So the frictions are high, and the tip, when you are trying to, for instance, do CPT testing, the tip resistance is quite high, and the slip friction is high as well, which indicates that will be problematic when you're trying to install any structure in that soil.
That's super interesting. And what have we been doing at NGI to look at these glauconitic soils?
We initiate work in the East Coast with one of our main clients, and we found that there was a glauconite. After we completed part of the project, we initiate this joint industry project where we start investigating and in understanding what were the conditions of this soil. We did some pile testing out of onshore in Massachusetts. The University of Massachusetts Amherst has been very keen on helping us out with this GIP. And now we are at the fourth phase of this project. We started with trying to identify from the physical behavior of the material all the way through in situ testing, pile testing, and now phase 4 is projecting to do some centrifuge testing as well.
Cool. And are we going to find these soils everywhere on the East Coast, do you think?
No, it's not everywhere. I think for what we have heard from some of our partners in the GIP, there's some zones that had more and some zones that don't have. Mm-hmm. So that's part of what the scopes of the GIP is at some point is to try to zone where we could find this material as well.
Are there any other soils that we see around the US coast that require maybe special attention?
Yes, of course. We have all sort of conditions in the US. So we see these glauconite materials on the northeast, and then towards the south of the East Coast and central, we see some carbonate materials as well. And I recently heard about a combination between glauconites and carbonates, which is making it a little bit more challenging. Gulf of Mexico, we're dealing with very soft clays towards the near shore. And as I mentioned before, West Coast is not any easy as well with the shallow rocks. So, yeah.
It was interesting. You said carbonate soils. Noel mentioned that as well.
Yeah.
I don't know if Noel, this is something that's been looked at extensively again in the oil and gas industry, but is probably a new topic for offshore wind. So what can we expect?
Yeah. Around Australia, obviously, the soil is dominated by carbonate materials. So these are materials, very fine shell-like particles. But you can also have zones where you have calcite participation. So you could be areas where it's a sandy-like material right up to something that's like a limestone. There's a lot of learnings and a lot of learnings about what makes them different to other soils from the oil and gas industry. But that's really come to the point that, these materials are well understood, and it's really about measuring their behavior and taking that appropriately into account in designs. For a lot of people in offshore wind, it's a new topic. But they're definitely materials that are well understood, and there's design approaches there, and it's really about just measuring their behavior and taking that into account appropriately into design, and understanding also how they may vary in a site. So understanding where you may have zones where you might have cemented material, that could be a specific challenge, say for installing a foundation. So it's just taking that knowledge and utilizing it in the design.
So it sounds like regional experience is key to these projects if you're going to be successful. In terms of where the offshore wind licenses are in Australia, is that an area where NGI is already working?
Yeah, no, definitely. We're like a lot of the first wind farms in Australia would be down in Gippsland region, so just off Melbourne. And that's an area we've been working in heavily, both for oil and gas development, but more recently to do with oil and gas decommissioning. And we're also working with several of the developers on their projects.
That's really exciting. What we know, these sites, they're huge. I guess one of the most important things is the techniques that we use for understanding the ground conditions and the behavior of the materials. And that's one of the main reasons we opened a laboratory in Perth and also have a laboratory in Houston, as well as the big lab that we've got here in Oslo. So it's pretty cool to be in a position now to have these 3 laboratories. But what do we do there in these offshore projects?
Oh, it's a huge range of things. The labs test everything from, the basic classification properties of soil. So it's water content, density, particle size distribution, and then a range of tests to characterize the strength. And that's the static strength, but also how the material behaves when it's cyclically loaded, because all of these foundations, they transmit cyclic loads into the soil, and this changes how the material deforms and how it behaves. So it's really important to do those tests and measure those properties, and then you can use those in design.
Mm-hmm. I mean, I guess that, again, that's something that we've looked at before with offshore projects. Are there differences between oil and gas and wind projects and how we do testing? I mean, Catalina, I don't know whether that also relates to the earthquake loading. What's your experience?
It does. I think you can totally relate the experience from oil and gas to wind, in the sense that you're looking at either wave loading, wind loading, or earthquake loading. And you need to be very familiar with what is the type of frequencies that these loads induce into your soil. So that's one of the things that you have to identify first. And then second, what is the type of condition that you want to represent or simulate with your soil testing. So for the cyclic loading that is due to wave, we can have set a 0.1 hertz frequency, or we can customize it depending on if we do a Fourier analysis of the load. And for earthquake, we could do two types of tests. We could do a test under 1 hertz, for instance, which is more typical for the earthquake loading conditions, where we are looking at the cyclic degradation, as well as a stress control, a cyclic testing where you can look at liquefaction effect. Mm-hmm. So those are the type of cyclic testings that we commonly do in the lab.
Cool. And I mean, I guess we've all seen this. We've got quite a lot of experience ourselves as engineers and running the different parts of the business within NGI also, but the projects have become so large. So, I mean, what are we talking about in terms of lab testing campaigns? Does the world have enough capacity for all this testing that we're doing?
Yeah, definitely. The projects are different. And I suppose, it goes back to how the projects are laid out. A typical oil and gas project, it would have areas where it have subsea structures. It would have areas where it have foundations. It's a limited number of locations. These wind farms, we're now dealing with areas that are many, many kilometers in size. And it's lots of different areas that need to be characterized, many boreholes. There's large amounts of soil, and potentially there can be a lot of testing that's done. But it needs to be optimized, and it needs to be optimized down to testing the representative materials across the site.
I think that's also been a topic. I mean, when we talk to our clients now, they're looking to optimize, looking to introduce strategies for characterization that I guess reduce the pressure points that we have within the market, for instance, within laboratory testing. So there's a lot of discussion of ground models in the work that we do. And I don't know, Catalina, could you describe what we mean by a ground model?
Yeah, a ground model, it definitely a representation of the ground conditions. It could be qualitative or quantitative ground model, depending on what is the amount of data that you have collected. From oil and gas industry, we mostly have work on qualitative ground models because we deal with very large areas. In those cases, as you mentioned, we will collect some boreholes and we identified what are the soil conditions, but we might have totally different soil conditions in one borehole versus the other one. So we try to kind of make sense out of how the soil units connect with each other. Whereas on the wind industry, the areas might be smaller, but the concentration of the points that we need to identify are a lot larger. And so that's why these ground models become a bit more on the quantitative side. And then we start looking at predictive ground models that can help us to optimize, as Noel mentioned, or geotechnical site investigation, because we don't want to be collecting boreholes every other or every single location, but try to set, for instance, optimize and collect CPTs, identify where the soil units that are important, and be able to collect samples, test them, and then connect everything with the ground model.
Mm-hmm.
Yeah.
Predictive. That sounds like we're pretty confident. Do they work? I mean, all of you seen these used in practice in your region?
Yeah, it's early days, I think, for predictive ground models, but they're definitely something that will be part of the projects. And, when done well and done with a good understanding of, the uncertainty in the geophysical data, the uncertainty in the geotechnical data, they're a good way of leveraging all the information that you have to provide you with the quantitative information that you need at the locations to do your designs. You can plan an investigation at an early stage with a very good understanding of the layout of the foundations, but things change, things move, and then you need a way to leverage that data and, if possible, use it at the locations that you may not have done as much intrusive investigation, and come up with quantitative parameters that you can use in the design.
When should you start with a ground model in a project then?
Well, I think the ground model, it really starts back at the desk study. That is the first ground model that you make of the site. It's based on the limited information you have, but it gives you an idea of what is the form of the ground and potentially the types of materials and how they may differ across the site. You then go out and you start doing your surveys. You do your geophysical survey. You integrate that information with your knowledge of the site to date. You do your geotechnical investigation. You integrate that information, and then as you're going on doing different surveys, you're all the time updating the model. But it really starts at the desk study, and then it allows you to plan things like your geophysical surveys. Plan them well. Make sure you're using the right equipment to target the types of materials and the types of things that'll be important at your site.
Oh, pretty interesting. That's something you see in the US as well, Catalina, with the development of ground models?
Yeah, we do. We not only in the US, but also across the Americas region. We have projects in South America where we have worked extensively on ground modeling, and now translating that experience from these projects onto the market in the US.
I guess South American offshore wind, that's not something we've talked a huge amount about, but you think that's on the horizon in the next few years?
I mean, there's some developments coming up in South America. I think out of what we heard, there's some intentions in Colombia, in Brazil also starting with it, but we have not so far explored much that market, but something that definitely we need to do.
So far, we talked a lot about what happens early on in the projects, in a way before they get installed, before they're in operation. Do we also get involved in things during and after the construction phase?
Yes, we do. We have the instrumentation and monitoring group, and we recently had been involved in a project where some turbines were instrumented. We were looking at lateral loading of this and how they were behaving. Also, there were some digital twinning analysis. So after this project has been completed, there are more other projects that will come on the same line.
Yeah. Talking about Houston, of course, that's not the only place that we're located in the US. We have an office in Boston as well. Could you tell me a bit more about that?
Yes, we opened our office in Boston about a year ago by our offshore wind manager, Federico Pisano. He's bringing a lot of experience from research and development. He was before joining NGI at TU Delft, and now putting all this into the practice. So we're looking forward to opening more the market and apply all this research onto consultancy services.
Excellent. So our instrumentation group, they work a lot together with offshore geotechnical engineers. And I understand we've got a big project coming up in Taiwan next year, Noel.
Yeah, so next year we're going to be involved in the installation of a large number of suction bucket jackets. So we'll have our teams with instrumentation and monitoring offshore during the installation, and that'll be providing all the information on how the foundation is going into seabed, the pressures, and it's used then to make decisions during the installation and confirm they've met their installation requirements.
So a bit like the Sea Green project that we had earlier?
Very much the same thing. Very much the same thing, but now in another region of the world.
Is that a region that we've worked in before?
Yeah, no, it's an area we've, in lots of different things. We've worked in Taiwan on some of the development of projects. A few years ago, we were also involved in an earlier phase of the Changhua project, where we did some field tests, and there we had all the instrumentation and monitoring on those foundations, and then used that information to help the design.
Cool. So that's a lot of different things. If you were to try to describe in a nutshell what we're doing, what would you say, Noel?
For NGI, it's really a value chain that starts with measuring the properties of material. That's why we have laboratories. We do site characterization to develop design parameters for sites. We then take that into design. But we can also take that into installation, instrumentation and monitoring, and later in operation, structural health monitoring, and aspects of decommissioning. So it's really a value chain that stretches from the earliest stage of the project to the end, but it's all anchored in understanding the grounds, its properties, and how these materials behave, and using that for the benefit of projects.
Brilliant. So thanks, Noel and Catalina, for the conversation today. We talked about a lot. I think I've definitely learned something, and I hope the people listening will also pick things up from our experience within the offshore wind market, what we've seen and what we've heard from others within our network as well. Hopefully this isn't the last time in the NGI podcast studio. So next time you come back to Oslo, we'll have to invite you back and see what's happening, what's developed with our work in the energy transition. And I should just mention as well that we do have a very good episode on geotechnical covering the history of the Suction Bucket Foundation as well. So please check that out. And otherwise, thanks for listening, and speak to you again soon.